Hi everyone, myself Jog Ramesh, working as assistant professor in EC department from St. Martin's Engineering College. Today I will present it on video lecture on logic gates. So introduction of logic gates. Logic gates are the functional block of digital circuits. They performing on two or more inputs. They produce single output. So the logic gates are actually you can act as a switch. The output will be one. Logic gate is on. The output will be zero. The logic gate is off. So in this diagrammatic and timing representation, the high level is represented in 1 and low level is represented as 0. So the logic gates are basically the fundamental building blocks of the logic circuits. The next one is the logic gates. Logic gate is an electronic device. So device that performing a digital program. Then it will performing the logical functions that are fundamentals to the digital circuits. Nowadays you are using more electronic devices. You are using logic gates, form of logic gates. For example, smartphones and smartwatches and some digital memory units. Then you are using some depending upon the input output, the logic based on the input of the logic gates. Next one is the classification of logic gates. You are using basically three type of logic gates. You are using basic gate. First one is the basic gates. Second one is universal gates. Third one is other gates or exclusive OR gates. Then basic gates, basically there are three types: AND gate, OR gate, NOT gate. Second one is a universal gate. There are two types. First one is NAND gate and second one is NOR gate. Third one is the other gates or exclusive OR gates. There is two gates, XOR gate and XNOR gate. Coming to basic logic gates. So basic logic gates, you are using a elementary building block of the logic gate digital circuits. They are performing two or more inputs. You are produced single output. Nowadays your basic gates you are created to the building block of complex gates. What is the and adder, decoder, multiplexers? You are creating multiple complex of the digital circuits. The next one is there are only few element fundamentals is three. First one is AND gate, OR gate and NOT gate. Just coming to AND gate. The AND gate is it will depend the two input AND gate. This is the two input output symbol and this is the truth table. So it is a symbol of two input AND gate. It is based on the inputs. You are using two inputs. They can produce the output. They can basic AND gate is the symbol. AND gate is the symbol of AND gate. It is the corresponding truth table. It will give the two inputs AND gate. It will produce the output. So you are using the basic AND gate symbol. You are taking A and B is the input. It will produce the output. C is the output. So basic AND gate operation is simple multiplication. C equal to A dot B. Simple multiplication A dot B. Suppose you are taking two inputs. You are using four input combinations. So it is based on the inputs you are using the combinations. So 2 power n combinations. N is the number of inputs. So n of number of inputs. So you are taking two inputs. 2 power 2. You are using 4 input combinations. You are taking 3 inputs. You are using 2 power 3. You are using 8 input combinations. So you are taking 2 inputs AND gate. You are using 4 input combinations. Suppose the truth table of AND gate, you are using the inputs and outputs. Taking input A and B is the input and output is C. So taking 0 0, so 4 combinations of 2 inputs get the requirement 4 combinations 0 0 0 1 1 0 1 1. This is the basic multiplication. You take 0 0, the input is 0 0, it will produce 0 into 0 equal to 0. So it will output is 0. Next one, you are taking our inputs is 0 and 1, A is 0, B is 1. The 0 into 1, it is multiplication of 0 into 1, it produces 0. So your output is 0. Next one, you will take A is 1, B is 0, that will produce the output is 0. Then 2 inputs are high, then 1 1, the A is 1 and B is 1, then output is 1. So you observe the truth table of AND gate, the output will be 1, output will be 1, there if 2 inputs are high or 2 inputs are 1, it is the AND gate. Coming to OR gate is like a OR gate, it is similar to AND gate. It gives the 2 inputs and it will produce the single output. It will produce single output. So it is a basic operation of OR gate is simple addition. So you take A is 0 and B is 0 and A plus 0 plus 0 equal to produce the output is 0. Next one, your input is 0, A is 0 and B is 1, then it will produce the output is 1. So 0 plus 1 equal to 1. Then it will take A equal to 1 and B equal to 0. So 1 plus 0 will produce 1. Next one, you are using input is A is 1 and B is 1. Then it will produce A plus 1 plus 1. It will produce the output is 1. It will observe the truth table. Output will be 0. Then 2 inputs are 0. It will produce the base. It will observe the truth table. The output of OR gate 0. It will be 2 inputs are 0. So next one, NOT gate. NOT gate is a single input, it will produce a single output. So it is called as an inverting gate. So it will output, it will complement or inverting of input. So it will give the A, the output is A bar. So it will give the output is A bar. So here is so this is a NOT gate. Here is the input and it will produce the single output. Output is B. Suppose you are taking A is the input is A and output is B. Output is B. So you are taking A is 0, the complement or inverting of input. So 0 complement is 1. It will produce the output is 1. Then A equal to the input is taking 1. It will complement or invert of input. So 1 complement is 0. It will produce the output is 0. This is the NOT gate. NOT gate will give the single output. It will produce single output. Next, coming to universal gates. Universal gates. NAND gate and NOR gate are universal gates. It will use, they can realize all the gates using NAND gate and NOR gate. So it is called as a universal gates. Universal gates are two. There are NAND gate and NOR gate. So it will any Boolean expression it will minimize the any Boolean expression using NAND and NOR gate. So it is called as a universal gates. NAND and NOR gate are universal. Coming to NAND gate. NAND gate. NAND gate is a combination of NAND gate, AND gate followed by NOT gate. NAND gate it will combination of AND gate it followed by NOT gate. Then it will give the two inputs. It will produce a single output. and it will AND gate is it will complement of AND gate. So AND gate, it will give the combination of AND gate and followed by NOT gate. So using A and B is the input of AND gate. NAND gate is this AND gate, it is followed by NOT gate. So we are using A dot B. AND gate, it will give the A dot B over. It is minimizing the gate of NAND gate. It is output side, we are using the circle. Circle is represented as NOT gate. So it will give the A and B is the input. So it will produce the output C equal to A dot B whole bar. This is the అట్లా మిస్టేక్ వచ్చింది ఓకే AND gate, it is followed by AND gate A and B, and it is followed by NOT gate. So we are using A and B is the input. So A dot B, then it will produce the output is A dot B bar. So you give the minimization of gate is A dot B. So A and B, it will give the output side, you will give the circle. Circle is represented as NOT gate. A and B is the input, so C is the output. It will produce the A dot B bar. A dot B bar. This is the output of NAND gate. So you observe the truth table of NAND gate. It is inverse of AND gate. So input and output. Input A and B is the input, C is the output. So we are taking 4 input combinations: 0 0, 0 1, 1 0, 1 1, 1 1. So it will 0 0, it will give the A is the 0 and B is 0, and C equal to A dot B bar. So 0 dot 0 whole bar equal to 1. 1. Next one, it will take A equal to 0 and B equal to 1. Then 0 dot 1 equal to bar equal to 0. Then 0 complement is 1. Next, it will be produce A equal to 1 and B equal to 0. B equal to 0. Then it will produce A dot B. A dot B equal to 0. 0 complement is 1. It is A equal to 1 and B equal to 1. 1 1, it will complement. Then 1 complement is 0. It will produce 0. Observe the truth table of NAND gate. Then output will be 0. The 2 inputs are in 1. The output of NAND gate will be 0. The 2 inputs are 1. It is a NAND gate. Next one is NOR gate. Next one is a NOR gate. NOR gate is a combination of OR gate followed by NOT gate and followed by NOT gate. Then it will use the NOT gate, it will give the 2 inputs, it will produce the output based on the logic, NOR gate logic. So it will use the A and B is the symbol of NOR gate. A and B is the input and it will produce Y equal to A plus B whole bar. It is the complement or inverse of OR gate. So it is A and B is the 0 0. You can take A equal 0 and A equal 0 and B equal to 0. It will produce the A equal to A bar B. So 1 plus 0 plus 0 equal 0. 0 complement is 1. So it is inverse of input. So 1. Then you can take the A equal 0 and B equal to 1, and 0 and plus 1 equal 1. It complement is 0. Next one, it will A equal to 1 and B equal to 0. 0 plus 1 equal to 0, 1, and it complement of 1 equal to 0. It will produce the output is 0. Next one, we will take both one inputs are 1 1. It will produce the output is 0. observe the truth table of OR gate, the output will be 1, the two inputs are in 0. Two inputs are in 0. Output is 1, two inputs are 0. So logic gates is the next one. Coming to next one. Realization of logic gates using NAND and NOR. So we are using realization of universal gates using NAND and NOR using other gates. So we are using, it is the implementation of NOT gate using NAND gate. So it is a single input NAND gate, it will act as a NOT gate. So it is as a, it is a using NOR gate. Using a NOR gate, the single input NOR gate, it acts as a NOT gate. NOT implementation of NOT gate using NAND gate and NOR gate. Single input NAND gate, it will represent as NOT gate, and it will single input NOT gate, it will NOR gate, it will act as a NOT gate. Next one, it is using implementation of AND gate using NAND gate and NOR gate. Using NAND gate, using two NAND gates to represent two NAND gates, it will represent as AND gate. It will realize AND gate. Next, AND gate. And two inputs, you are using NOR gate, it will implement an AND gate. It will using three gates, three NOR gates, it will realize the NOR gates. Suppose realization of AND gate using NAND gate. Suppose you are using two inputs, two NAND gates, single input NAND gate and A and B using AND gate using NAND gates. It is A dot B bar and is equal to A dot B. It is a single input. Using two NAND gates, it will realize the AND gate. Next one, you are using AND gate, NAND gate using NOT gate. NAND gate using implementation of AND gate and NOT gate. It is a single input NAND gate. It will act as a NOT gate. The output is A bar. Output is A bar. And NOR gate is using for three NAND gates. Using three NAND gates, it will realize OR gate. So A bar and B bar will give the third NAND gate. NAND gate is A bar and B bar. So A bar plus B bar, A plus B. So it will realize OR gate using NAND gates. It is a AND gate, NOT gate and NOR gate. Next one, NOR gate using OR gate, NOT gate and NOT. So implementation of NOT gate using NOR gate, single input NOR gate, it will act as a NOT gate. So A is the input, it will complement of input. So A equal to A bar. It will use the implementation. Next one is AND gate. AND gate using three NOR gates. It will implement realizing the AND gate. You taking two single input NOR gates. A and B single input NOR gates. It will give the two inputs of NOR gates. It will give the third NOR gate. It will output is A dot B. It will using 3 NOR gates. It will realize A bar and B bar. It will realize NOR gate. Next one is OR gate. NAND gate implement using OR gate. So using 2 NOR gates, using 2 input NOR gate, single input NOR gate, it will produce output is A dot A plus B. This is the using 2 NOR gates using OR gate, implementation of OR gate. This is the how you using realization of basic gates using NOR gate. Coming to next one, other gates. Other gates, exclusive gates are digital logic gates. Digital logic gate, the produced output and it will based on the exclusive OR and exclusive OR operations. Then they are used to arithmetical circuits like adders, subtractors, multiplexers, using adders and detectors. Then exclusive gates of the exclusive gates are two types. What is the exclusive OR and XOR and XNOR? Coming to XOR gate. XOR gate, it will use it for the 2 inputs and it will produce the single output based on the XOR gate operation. XOR gate operation. XOR gate used to produce the output depending upon the combination of input of the XOR gate operations, Boolean operations. Suppose this is the symbol of XOR gate and is the truth table of XOR gate. So it is XOR gate, it will A and B is the input and it will produce the single output. X is the output. So it will so XOR gate symbol A and B is the input, it is XOR gate. It is a Boolean expression of XOR gate. Suppose Y is the output. So A dot B bar plus A bar dot B. This is the Boolean expression of output of XOR gate. XOR gate. Next one is XNOR gate. XNOR gate is a logic gate to performing based on the exclusive NOR gate, right? Exclusive NOR gate based on the input, two inputs, it will give the single output. You are taking 2 inputs, A and B is the inputs, and it will A bar truth table of the NOR gate is 0 0. The input is 0 0, and it produced output is 1. Then it will give the A equal 0 and B equal 0. The output is 0. Next one, the input is A equal 0 and B equal to 1. Then output is 0. Next one, it will give A is 1 and B is 1. It will produce output is 1. Then we will take A and B. The logic operation of our logic Boolean expression of XOR gate is A dot B plus A bar dot B bar. So you give the output output Y equal to A plus exclusive B whole bar. This is the XNOR gate operations. Then you can realize the AND gate and OR gate using NAND gate and NOR gate. So you are using realization of XOR gate and XNOR gate using universal gate. AND gate and using NAND gate, the realizing of XOR gate. XOR gate, you are using 4 NAND gates. You are using 4 NAND gates, you will realize the XOR gate. A and B is the inputs. A is the inputs, then give the inputs to the AND gate, then it will, the final output it will give the 2 inputs NAND gate. 2 inputs NAND gate. So output Y equal to A dot B bar plus A bar dot P bar. Using 4 NAND gates, it will realize the XOR gate. It will realizing of XOR gate using NAND gates. XOR gate using 4 5 inputs, 5 NAND gates, using 5 NAND gates. A and B is the input, then we are taking the input NAND gate. The final input is, it will give the single input, single NAND gate. Finally, you can use the 5 NAND gates. It will be implementation of the XOR gate. The final input will give the XOR gate. So Y equal to A dot B plus A bar dot B bar. It is the XOR gate. Realizing using NAND gate, it will realize the XOR gate using 5 NAND gates. It will realize the 5 NAND gates. The A and B is inputs. It will give the 2 input NAND gates, and the final output it will give the single NAND gate, single input NAND gate. It will realizing XOR gate and XOR gate using NAND gate. Next one is using for NOR gate. You are realizing XOR gate and XNOR gate. XOR gate, XNOR gate. You using for 4. Use the XNOR gate using 4 NOR gates. 4 NOR gates. You are realizing NOR gate. A and B is the input. So using taking 2 NOR gates, the 2 NOR gates output will give the other NOR gate. Single NOR gate, the output is A dot B plus A bar dot B bar. This is the XNOR gate realizing using 4 NOR gates. It will realize XNOR gate. Then you can give the XOR gate. XOR gate. Realizing the XOR gate using NOR gates. You are using 5 NOR gates. You are realizing NOR gates. So you are using taking 5 NOR gates. A and B is the inputs. The final input, it will give the single NOR gate. Single NOR gate. It will equal to, this is using 5 NOR gates, it is realizing XOR gate. So final input is A dot B bar plus B dot A bar. This is the realization of XOR gate using NOR gates. 5 NOR gates using XOR gate. Next, coming to current page. So the advantage of logic gates, basic of modern computing, high speed, low cost, and small size, and high reliability. They are the advantage of logic gates. Advantage of logic gates is basic of modern computing, high speed, low power consumption, small size, and high reliability and low cost. The next one, coming to applications of logic gate. Applications of logic gate. Here is the digital computers, it is arithmetic operations, security purpose. You're using digital, you're using arithmetic and logical operations, digital computer signal processing, then digital signal processing, communication systems and control systems. Next one is the application. Video.
Now we'll look at the video and repeat that.
Now we'll look at the video. Video is the NOT gate. NOT gate, you are giving the 0, 1 is the input, it will produce the output is 0. Next one, it is AND gate. 0, it will give the 0, 0 is the input and it will produce the output is 0. Next one, it will taking input is A is 0 and B is 0 and it will produce the output is 0. Next one, it will produce A equal to 1 and B equal to 0 and it will produce the AND gate output is 0. Next one, 1, 1. A is 1 and B is 1. It will produce the output is 1. Next one is the OR gate. OR gate will produce the 0, 0 is the okay. Next one will 0, 0. Then 1, A is 1 and B is 0. It will produce the output is 1. Next it will 0 and 0. A is 1 and B is 1 and it will produce the output is 1. Next one is the NAND gate. NAND gate, A is 0 and B is 0 and it will produce the output is 1. At NAND gate, it will complement or invert gate of AND gate. So it will give the 0, 1, 0, 1 and it will produce the output is 1. And 0, 0, 1, 0, then it would produce the output is 1. Then finally A is 1, B is 1, then output is 0. Next one is NOR gate. 0, 0, the output is A plus B over bar, then 0, 0, then output is is 1. 0, 1, the produced output is 0. Then 1, A is 1 and B is 0, the produced output is 0. Then finally you can get 1, 1, the combination of 1, 1, that will produce the output is 0. Next one, XOR gate. XOR gate, 0 input A is 0, B is 0, it will produce the output is 0 and G is 0, 1, 1, it will produce the output is 1. And then 1, A is 1 and B is 0, it will produce the output is 1. And finally 1, 1, taking 1 and 1, it will produce the output is 0. Thank you.